Hey guys, in today's lesson we're going to talk about logarithmic functions and their graphs, which is found in section 3.2 part 3. Our objectives are to recognize, evaluate, and graph natural logarithmic functions and to use logarithmic functions to model and solve real-life problems. So the natural logarithmic function, the most widely used base for logarithmic functions is the number e, where e is about 2.7182. The function defined by f of x equals log base e of x equals the natural log of x, where x, as long as x is greater than 0, and it's called the natural logarithmic function. So essentially now what we're seeing is up until this point we've used like log base 10, oops, didn't mean to move that. We've used log base 10 of x, and we would call that the common log. Okay, now we're looking at log base e of x, and that's the same thing actually as us looking at ln. So if you ever see ln on your calculator, it means the same thing as log base e of x. Okay, and we call it the natural log. So we will use a calculator to evaluate the following expression. So here, ln again is an actual button. So we'll just type that in. And so if you type those in, you get about 0.693 for the first one. On the second one, you get about negative 1.204. The third one, you get exactly 2. And the last one, you get an error. And again, the reason why you get an error on the last one is, think about it. If ln means the same thing as log base e, and specifically this one is saying log base e of negative 1. Remember, we would say bay. So for us, this is really like saying e to some exponent equals negative 1. But no number to any exponent will ever give you negative 1. So that's why we have an error. Okay, it's not possible. All right, here's some properties to remind ourselves of. Again, they're very similar to when we had log. So the natural log of 1 is 0 because e to the 0 power is 1. So imagine again that you essentially had a little e there for log base. Actually, I won't say that. Imagine with that ln, it's really log base e of 1 equal to 0. And again, this justifies it. Okay. On the second one, the natural log of e is 1 because e to the first power is 1. The natural log of e to the x equals x, and e to the ln of x equals x. And essentially it's because they kind of cancel. They're inverses of one another. And in the last one, it says if ln of x equals ln of y, then x equals y because they're 1 to 1. So now we're going to use those properties to solve some natural logs. So here we go. If I have the natural log of 1 over e, how do I simplify that? So if you are dividing natural log, that is technically subtraction. So that's the natural log of 1 minus the natural log of e. Now I should make that L bigger because that's an L. Okay. The natural log of e is really like seeing log base e, right, of 1. E to what power gave you 1? Actually, let me just go ahead and write that. Log base e of 1 minus log base e of e. Okay. E to what power gave you 1 is 0. E to the 0 power gave you 1. Minus e to what power gave you e? It's 1, so our answer is negative 1. Okay. On the second one, the natural log of e to the 0 power, essentially because that power is there, we need to move it to the front. So this really becomes 0 times the natural log of e. 0 times anything, guys, is 0. So we are done. Let's take a look at our next problem. As our try, we have the natural log of e squared. Again, the powers move to the front, so this becomes 2 times the natural log of e. So we'll want to find what the natural log of e is. So remember, a natural log of e is really log base e of e. So this part here, log base e of e, is actually 1 because e to some power gave us e, so it is 1. And 2 times 1 gives us 2, so 2 is our final answer. And then the last one, 2 ln of e, well, it's actually the same thing, right? Because it's essentially this step forward, right? So the answer is 2. So though they look differently in the beginning, they are actually the same answer. All right, example 9. So we would use our graphing calculator to give us the domain of these. And without sketching them, I'm just going to give you the answers. But the natural log of x minus 2 in interval notation would be 2 to positive infinity. In set notation, it would be x such that x is greater than 2. Okay, so again, just depending on how you want to see it. The natural log of 2 minus x in interval notation would be negative infinity to 2. Or I would say y such that y, it's not y, is it? Sorry. X such that x is less than 2. And the last one, h of x equals the natural log of x squared. In this case, it's going to be all real numbers except 0. So in set note or interval notation, I would say from negative infinity to 0, and then 0 to positive infinity. In set notation, I would simply say x such that x is all real numbers except x equal to 0. All right, let's take a look at our last problem. So it says students participating in a psychological experiment attended several lectures on a subject. At the end of the last lecture and every month for the next year, the students were tested to see how much of the material they remembered. The average scores for the group were given by the human memory model f of t equals 75 minus 6 ln of t plus 1, where t is a time in, supposed to say months, not onths. Haha. Anyways, is between 0 and 12. What was the average score on the original exam at the end of 2 months and at the end of 6 months? So essentially, this is nothing but a substitution problem. They gave us a long backstory and everything else, but it's just a substitution. So to test or to know what the average score was on the original exam, that would mean that the month was equal to 0. So in other words, t was equal to 0. So to find f of 0, all we do is substitute. So 75 minus 6 times the natural log of 0 plus 1. Essentially, that's going to be 75 minus 6 times the natural log of 1. If you type that into your calculator or just use mental math, you will get 75. Okay? At the end of 2 months would be f of 2. So that'd be 75 minus 6 times the natural log of 2 plus 1, which means 75 minus 6 times the natural log of 3. That would be about 68. And then finally, at the end of 6 months, that'd be f of 6. So that means 75 minus 6 times the natural log of 6 plus 1, which equals 75 minus 6. 6 times the natural log of 7, which finally is going to be about 63. So over the course of 6 months, these people pretty much held their scores decently, but I'm sure after a year it'd be a lot worse. Either way, we are done with this lesson. So if you have any questions, please be sure to come see me for tutoring.